Hi everyone, my name is Renata Castelo Branco, and I'll be presenting the collaborative Algorithmic Design Notebook, a work also authored by Inês Caetano, Inês Pereira, and António Leitão. The contemporary architect faces several challenges. The complexity of the projects we're designing and the requirements that they must fulfill force the integration of different expertise, so we now have more stakeholders involved in the design process. And these stakeholders need to communicate. And while drawings and technical documentation may suffice for the typical small-scale architectural project, none of it applies to algorithmic design. No one drawing, plan, section, perspective even, can represent the whole that is an algorithmically designed project. In algorithmic design, or AD for short, instead of building the digital model, we instead build the program that builds the digital model. And this allows us to parametrically describe the model so that we can generate not one design, but multiple versions of that design. The problem with algorithmic design, and collaborative algorithmic design in particular, is that code is in fact difficult to understand and to relate to the 3D building that it represents, particularly if we're reading a program that was written by someone else. So we really need to improve the representation that we currently have for AD in order to help these guys, all the stakeholders involved, understand the programs that are being shared. Several approaches promote program documentation as a way to explain programs. The problem with these systems is that text doesn't really suffice to document or to explain something that is naturally visual. This is the sort of documentation made in architecture. The sketches the architect does while designing are frequently related to the parameters he's then going to use in the program. So what we defend is that all this information that is produced during the design process should become part of the program itself, to help explain it, document it, everything for other readers in the future. Simultaneously, we want the development of an AD program to be an interactive experience. Programs should be done interactively with testing all the way to help people comprehend programs when writing them and when reading them. We came across computational notebooks that partially support all these ideas. And as an example here is a notebook done of an adaptation of the Eisenberg School of Management Hub. So these tools already allow for incremental development, interactive testing, and also the intertwining of code with textual and visual documentation. So all those things that we are defending should be a part of the program itself. What we want to do is to extend the notebook concept to improve the experience of developing and sharing AD projects. And for that, the ideal AD notebook should allow for, first of all, interactive code development, second, collaborative development, and third, storytelling. When I talk about interaction, I'm talking about enabling the incremental writing and testing, and also the reactive manipulation of parameters. And this can be achieved using sliders, toggles, and even the cell-by-cell development logic of computational notebooks. Storytelling is about preserving the trail of program changes and the tests made along the way, documenting them and explaining them as we go. And this can also be done in currently existing notebooks. Now, collaboration here includes the ability to create programs without local dependency so that these results can be reproduced by anyone, anywhere. And collaboration is the focus, the primary focus of this paper. So we divided 3 possible collaboration scenarios. We divided them in 3 types: pair programming, synchronous programming, and independent programming. And I'm just going to explain them briefly. Traditional pair programming involves 2 people, one implementing and the other supervising, but remote collaboration allows for other possibilities, like distributed pair programming, where the exact same scenario happens, but each person is on his own computer, which means that we can have more than 2 developers now involved in the process collaborating remotely. This can be done in 2 ways. First of all, screen sharing. One person shares his view of the code, essentially like a mirror. Colleagues can just watch and comment on the code that is being developed. And most communication tools nowadays already allow for this, for screen sharing. But there's a second way, which is terminal sharing. And here, colleagues can also edit the code that is being shared, although it's still just running on the one machine that is sharing. Used together is an example of a communication tool that allows for this. Synchronous programming, users are working on the same program file, sharing the same programming environment in real time. I guess it's the coding equivalent to the shared document workflow popularized by Google Docs that we all know, And some notebooks already allow for this. So we have, for instance, NextJournal and DeepNote. In independent programming, coworkers separately develop different program files or different sections of the same file, and then they have to merge them or combine them from time to time. And of course, we can use normal file sharing apps like these two to share the files, but it's always better to use specific applications for programming work like GitLab or GitHub. The thing is, even using these, merging notebooks can be challenging because of their underlying representation. Specifically, if two users were changing the exact same code piece, like whose version should we keep in the end, right? So for some notebooks, we require more elaborate merging systems to resolve the conflicts that may arise. Time-wise, they all serve different phases of the development process. So independent programming is usually the main strategy because it's more productive, because projects can be divided and distributed, while pair programming is most beneficial for difficult developments where the expertise of several coworkers is required. Synchronous programming is most useful when time runs short, since it allows for multiple developers to be editing the notebook at the same time. So this is how a hypothetical collaborative AD process could look like. To evaluate the proposed collaborative workflows, we developed a case study inspired by the Rhythmic Gymnastics Center in Moscow. And an AD notebook adaptation of this project was developed in 5 working days by 3 architects. We used the Julia programming language and the Capri AD tool to do the project. And we essentially selected the tools that we considered most suitable to test out the 3 collaborative scenarios. So we chose 3 notebooks, Jupyter, NextJournal, and Pluto, and 2 version control systems, GitHub with and without NBDime for merging, 2 communication platforms, Skype and NewsTogether. And here's the schematic chronogram of the project. So we have 5 working days that took us to develop the project, the 3 developers involved in the process, what each one did, and the tools that were used in each stage. So the notebooks used were, first of all, Jupyter to explore storytelling, Pluto for its reactivity, and NextJournal for real-time collaboration in synchronous programming. Share tools, GitHub to share both the Pluto notebook and the Jupyter notebook. And Pluto didn't need a specific merging system, so here you see an image of the GitHub desktop application autonomously merging the 2 independent versions of the Pluto notebook, submitted in this case by developer 1 and 2. They're also sharing a conversation on Skype just to see if anything goes wrong. There are no conflicts. Then Jupyter, on the other hand, did require a specialized merging system. GitHub could not sort out the merges on its own, so conflicts had to be resolved using NBDime. So here you're seeing the same workflow for Jupyter, but we have to resort to NBDime, which is a specific notebook file merging system to sort out the conflicts. Next off, communication tools. So we used Skype for discussing ideas mainly and NewsTogether for more in-deep help sessions. So while in Skype we're just sharing screen, in NewsTogether we're also sharing the terminal, which is a lot more helpful to talk about code. You can see here in NewsTogether that developers 2 and 3 are working on the Jupyter notebook, and you can see both cursors working in the same cell. This facilitates communication over code because we can actually point at things and explain them by demonstrating and by typing instead of just verbally trying to explain our ideas. So in the timeline, we have pair programming here and there essentially being used every day a bit, and synchronous programming attempt here with NextJournal on day 3, and the rest pretty much is independent programming. We ended up with 2 final notebooks, one developed in Jupyter and the other in Pluto. And I'm showing you both of them here. So on the left, we have Jupyter and on the right, Pluto. These notebooks have very different philosophies on how people should develop programs. And it was really interesting to explore both. So Jupyter is better for storytelling because it allows us to keep multiple definitions of the same function in the notebook. But Pluto has a more reactive nature. So everything is always running. There can be no repeated definition. So it's a lot harder to keep storytelling. Also, we have to comment every example that we make that we're not trying to test at the moment, because if everything is always running, then it's just really computationally heavy and unnecessary. But it's a lot more interesting in terms of reactivity. In conclusion, given that all of these notebooks have different advantages and limitations, we don't endorse one specific one. We just instead formulate these 3 main principles that we really believe an ideal notebook should have: interaction, collaboration, and storytelling. And as future work, we plan on researching techniques to automatically hide intermediate steps to retrieve like a summarized version of the notebook for presentation purposes in the end. And we also plan to address education scenarios. So we think we can ease the task of learning AD, particularly in remote teaching. If you want to know more about our research on this or any other related topic, here's our contact lists. Feel free to reach out.